Hello and welcome to another Mr. Watson YouTube video. If you'd like to see me go through another topic, then please comment down below. Also remember to check the video description for any additional information. Welcome to this video on integration. In this video I'm not going to be taking you through a proof of integration or where it comes from or anything like that. We're just going to look at how you would answer some simple integration questions. So if you can already integrate things like this, then this video isn't going to help you out at all. But if you don't know what integration is, then hopefully after watching this video you'll be able to answer some simple integration questions. So like I said, I'm not going to tell you what integration is or what it means or anything like that. Let's just get people actually doing something. So in a previous video I looked at differentiation. I said that if you have an equation of a curve, say y equals x squared plus 4x plus 3. If you differentiate that, and again I'm not going to go through what differentiation is here, this video looks at integration. If you differentiate that, that is what you get. Okay, well integration, if differentiation takes you that way, integration is what takes you that way. So differentiation is basically the inverse of integration, or integration is the inverse of differentiation. Okay, so this here, well, we know what it needs to look like in the end. We know it needs to look like this. So much like differentiation, where if you have y equals ax to the n, and the derivative of that is n minus 1. There is something similar for integration as well. So with integration, if you have ax to the power of n, then the integral of that is, and this sign here is like the symbol that we use to say that something has been integrated, then what we do is we say that that is ax to the n plus 1, so we increase the power by 1 and we divide by that new power, and that's it. So how would that work here? Well, if we integrate this, what does that give us? Well, this thing here, so 2 is going to be a, x is obviously x, and n here would be just 1. So this here will become 2x to the 2, so we increase the power by 1, and then we divide by the new power, just 2. This here, this is effectively x to the power 0 there. X to the power of 0, remember, is 1. So what we do there is we increase the power by 1 and we divide by the new power. And then here you can simplify this. You can say that that is x squared plus 4x. And as you can see, this is very similar to this here. But we are missing the 3. So what we need to do here is we need to say, okay, well, we're going to add on some constant there. So when you differentiate something, you can sometimes lose information. Like here, this plus 3 disappears. When you integrate again, you can't just magic that up out of nowhere. That information has been lost once you differentiate it. So here we add a constant. So let's take a look at this example here that I've put down. Now you'll notice here this says the integral of 3x to the power of 3 over 4, and then this part here dx. So that there I didn't put on the end. That just means what you're integrating with respect to. So here we're integrating the x terms. But don't worry about that for now. So let's try and do the integral of 3x to the 3 over 4 dx. So the integral of this with respect to x. Okay, so what is that? Well, you're going to have to increase the power by 1. So 3 over 4 plus 1 will be 7 over 4. So that will be 3x to the power of 7 over 4. And then we divide by the new power, 7 over 4. And don't forget plus c. And there we go. Now normally then you would simplify this somewhat and you would say that that would be 12x 7 over 4 over 7 plus c, but it doesn't really matter. Here I'm more concerned with showing you how, how this works, how if you have the integral of ax to the n, that is this thing here. So let's try another question. I've got a sheet here. I'll put the link to this in the video description, and we're just going to look at some of these questions here on part of question 2. So if you want to pause the video here and attempt some of these, then go right ahead. I wish you the best of luck with that. And on this next part of the video, I will take you through, say, A, F, K, and H, let's say. And I've not picked them for any reason. Okay, so let's take a look at. In fact, I'll also do that one as well. So let's take a look at some of these questions then. Okay, question A. Find the integral of 2x plus 3. And you'll see here that the brackets are around this. This just means that this dx term is multiplied by both of these. So we can rewrite that and we can say that that's the integral of 2x dx plus the integral of 3 dx, if that's what you want. But you don't need to integrate it this way. You can just do the whole thing in one go. So here the power is 1. So we integrate that, we increase the power, and then we divide by the new power. The next one, the power here is 0. Remember, that's like a 3x to the power 0. So increase the power by 1, you'll get 3x to the power 1, divide by the new power. So this will then be, if you simplify this, that is simply x squared plus 3x, and don't forget the plus c. It's quite important, that. Question F is the integral of x squared minus 3 dx. So here you want to multiply out this bracket first, and you want to say that's the integral of x cubed minus 3x dx. So that will be x, that will be power 4, increase the power by 1, divide by the new power. The next one will be 3x squared, because we increase the power by 1, divide by the new power. Don't forget the plus c. And there we go. That's question F. Let's try H. So the integral of 3x 4 plus x squared minus 6 dx. So this here, increase the power by 1, 3x to the power 5, divide by the new power. Next one, increase the power by 1, x cubed, divide by the new power. The next one, 6 will be 6x divided by 1 plus c. So here, when you simplify that, of course, you would just say there that that is just 6x, not the way I've written it there. So in time, you get used to what some of these things are. In time, you'll get used to the fact that if you have the integral of 6, that will just be 6x. So here, the integral of 3 with respect to x, that part there is just 3x. If you have the integral of 4, that will be 4x. I should say there that that's with respect to x. The integral of 17 with respect to x is 17x. So if you ever have just a number, then you have just AX. Okay, so that's question H. Let's now try question I. Okay, so question I is the integral of 2 plus 1 over x squared dx. Now how do we do that? Well, one thing that you don't do is the following. You don't say that that is 2x plus 1 over x cubed over 3. You don't do that. Okay, so this here is wrong. What you should get into the habit of doing, whenever you have a fraction like this, you should always write it as a negative power, and you should say that that is x to the power of minus 2. And then do your integration as normal. So that will be 2x. And then here you increase the power by 1. So that will be x to the minus 1 divided by the new power. And there we go. So as you can see here, this is a totally different result to this. So that will then be 2x minus 1 over x plus c. I've rewritten it back in terms of 1 over x rather than having the negative power, but you can leave that in. You can say that's 2x minus x to the minus 1 plus c. That's perfectly acceptable as well. Now you see now why I added that one in as well. Okay, so this is similar. We're going to have a negative power here as well. So we have x squared 2x to the 4 minus 3 dx. If you're watching along now, I suggest that you pause the video and attempt this question. So here you need to multiply out the bracket. So you'll have 2x squared over x to the power 4 minus 3x squared. All that with respect to x. And then here we can simplify this. We can say that's the integral of 2x to the minus 2 minus 3x squared dx. So here powers, if you're dividing you subtract them. 2 subtract 4 is negative 2. And then you integrate that. So you say increase the power by 1, you'll have 2x to the minus 1 divided by the new power. The next term, increase the power by 1, you'll have 3x cubed, and then divide by the new power. And don't forget the plus c. And then here you can simplify this somewhat. You can say that that is minus 2x to the minus 1 minus x cubed. And there we go. And don't forget as well the plus c. So this is basically how you integrate. Now you'll notice here that some of these numbers are quite specific. If you try and integrate x to the minus 1 with respect to x, you see here that this here was x to the power of minus 2. This was, where was it? This here is x to the minus 2. Why is there no x to the minus 1? Because if you follow the rule, that's going to be x to the power of 0. If you increase the power by 1, divide by the new power. Okay, well, if you've ever tried dividing by 0 on your calculator, then you should know that you can't do that. So there is a way that you can integrate this, but that's a video for another time. So if you do practice any of these, any questions, obviously practice with the sheet that I'm going to link in the video description. But if you practice with any questions that you find online and you see this, and then you end up dividing by 0, thinking, well, what's that? This you can't do using this method. This you need something else. So hopefully me taking you through a few questions there, hopefully that's been very helpful. I will link this sheet in the video description. I think there is also an answer sheet for this as well, so I'll also link that in the video description. Thank you very much for watching. I really appreciate every view and every subscriber. If you would like to see me go through another topic, remember to leave a comment down below, and I'll see you next time.